There is one thing which is necessary in life, which is to breathe, and maybe it will be a surprise for you, but every one of us on a daily basis breathe about 14 kilograms of air, and just this simple idea means that the quality of the air that we breathe is essential. CAMS stands for the Copernicus Atmosphere Monitoring Service. It's one of 6 thematic services under the European Union Copernicus program. And what we do in CAMS is to develop information services from these satellite observations, as well as from in situ observations and modeling. So over the last 7 years, I think we've made gigantic progress in terms of bringing more environmental information to a wide range of users, be it policy makers, down to the citizens who benefit from air quality information, for instance, in smartphone applications, in TV bulletins, etc. Now, one key area of development is trying to infer emissions of CO2, carbon dioxide. In short, it's a way to measure the progress that the countries in Europe and in the world are making towards the Paris Agreement. We very well know that all the countries in the world have to reduce their emissions of CO2. And what Copernicus is tasked to do in the coming 7 years is to give Europe and the world a capacity to see how the progress is being made. For doing this, the Copernicus program will be launching dedicated satellites, and the countries in Europe will be reinforcing their observation capabilities from the ground. So machine learning is a new way to address all problems that we have. We are using machine learning on the side of the acquisition of data. There is an increasing number of data that become available to us. Machine learning can help with mining what's in the data. The systems are producing vast amount of data. It's about sometimes finding the needle in the haystack. And machine learning has this capacity to detect things that you didn't know existed. And it's very useful for atmosphere or for climate, because we don't know all about all the couplings and the interactions in the complex Earth system. One application is currently very relevant. It's about a COVID situation, and more precisely, trying to estimate how the changes in human activity because of the lockdown situation have affected air pollution. To do that, we've been using machine learning by trying to estimate what would have been the months since February of last year without lockdown measures. So it was about training a system to learn how air pollution depends on weather parameters, etc., different types of things, so that using the weather parameters of 2020, we could estimate what would have been 2020 if it has been business as usual. And by making the difference, we have a clean way of assessing how these emissions have changed due to the different policies that have been put in place by the governments. And it's a very useful information, because if we gather this at the scale of Europe, it's a study that we've made with the London School of Hygiene and Tropical Medicine. We could look at the efficiency of different types of measures, such as forbidding traffic or such as closing public institutions, and a palette of measures that have been taken by governments across Europe to see which one of them were most effective in reducing air pollution. So it's useful for in the context of COVID, but of course, once this COVID situation will be away, it also gives an handle for our government to assess what would be the best measures to reduce in the future air pollution long term, building on the knowledge that we acquire this year.